Welcome back to another Build Day TV. I'm here once again with my friend Alastair, and today we are talking about connecting a VPC to on-premises. What does that exactly mean there, Alastair?
Hey, Jeffrey. Well, we've looked at building a virtual private cloud, a VPC, your own data center inside AWS. We looked at how you glue it all together and connect it to the internet. And we looked at, in the last video, we looked at creating two of those and attaching them together. So we've done quite a lot of networking inside of AWS. But what we haven't done is linked it back to our on-premises network. And a lot of organizations end up with this hybrid cloud kind of scenario where some of their resources live in AWS and some live on premises in their data center, the same as they have for the last 20 years.
Okay.
So it's a really common thing to see new things being built in AWS, but that they need to be connected to what we have on premises. And it might be that we're changing from having our customers phone to staff that live in our offices and have access to our on-premises resources. We're changing that so customers go to a website and they're accessing the same information and the same back-end systems that run on premises, but they're now accessing them through a website that's living on AWS.
Okay.
We need to join those together, and we usually want to join them together in a way that's private and secure rather than doing it all over the internet.
Yeah.
It's a really common idea that we have this hybrid cloud deployment. And I know AWS didn't originally say that there was ever going to be a hybrid cloud. They said that there is only ever one future compute model, and that it's the AWS public cloud. But that message has changed over the last 5 years. And the reality is that there's lots of stuff that is going to remain on premises because there's no huge value in changing something that's never accessed from anywhere else. So new things are absolutely being built in AWS, but existing things often remain on premises. So joining together in hybrid cloud is really important for a lot of large organizations. So we can connect our on-premises network through the public side of our VPC. We've already created internet gateways and we've made things accessible over the internet. And we could use that from our on-premises environment. And that's what I've been showing you from my on-premises environment here in my home office.
Okay.
I've been connecting over the internet to these services on AWS. And we've usually shown you the alspizza.info, the Al's Pizza website, living inside my VPC. So in that way, I could access from my on-premises the same things.
All right.
So it goes in through an internet gateway, goes through a public IP address, has NAT in front of it. But we often want private side connectivity. So the public side uses the internet gateway, uses public IP addresses and goes over the internet. But we often want to have our connectivity to go over a private network that's not exposed to the internet. We might want to have our on-premises resources accessing part of our AWS-based resources, but aren't accessible to everyone. So this private connectivity through private IP addresses and that's never exposed to the internet is a really important aspect of doing networking with AWS.
Okay.
And although I've said never over the internet, we're actually going to show VPN connectivity. So the internet is our connection mechanism. It's just that we hide it inside a VPN. So we secure it rather than having it publicly accessible.
What kind of VPN are we talking about? Because I've had some pretty bad experiences on VPN connections.
Yeah, so we're going to be using an IPsec VPN, and we're going to do it as an edge-to-edge, basically bridging the two networks together. And so a lot of your experience of using a VPN is that there's a big overhead, and that transferring data over the internet is faster than over the VPN that uses the same internet connection.
Okay.
And that's absolutely going to be the case here. When we're using IPsec, we're encapsulating the network packet we want to send inside another network packet.
Okay.
And that will absolutely introduce overhead.
Okay.
So this is not the fastest way to connect AWS VPC to your on-premises network. In a later video, we'll take a look at Direct Connect, or DX as it's sometimes abbreviated. This allows us to have a 10 gig dedicated Ethernet connection.
What type of delay are we talking about when commands move back and forth?
So for network transfers in this, the VPN doesn't add a significant amount of overhead. There's encapsulation, decapsulation for the security payload component. That doesn't add a huge amount of latency. What it does is decreases the amount of throughput you can get.
Okay.
Because it's network packet inside another network packet. And that tends to be what causes the issue, that you have a relatively slow internet connection and then you're putting in some additional overhead in terms of throughput. Tends not to be a huge issue on the latency of connections. Particularly for me, here I'm in New Zealand and my nearest AWS region is in Australia, which is 2 time zones away. So the actual physical distance is the determining factor in the latency for me. A little different if you've got AWS regions closer to you.
That's true. That's true. All right. Let's move on then.
So assuming we're going to use this private side, so we're going to cover here private side connectivity, in which case we need a virtual private gateway attached to our VPC. So it's virtual private gateway is abbreviated VGW. Apparently VPG is used for too much else, so VGW is the shortening we usually use for a virtual private gateway, virtual gateway. And this is attached to a particular VPC, and it's attached to connect to your private network. So we have an internet gateway for public, we have a virtual gateway, a virtual private gateway for private side connectivity. And it allows us to link outside of AWS on that private side. So peering connections let us stay on the private side inside AWS, and the virtual gateway allows us to connect on the private side beyond AWS.
Okay.
And we're going to use a VPN for that connectivity. And the VPN lets us get up to officially around 1.25 gigabits per second worth of throughput.
Okay.
So if you have a fast enough internet connection, AWS has ridiculously fast internet connections at their edge locations where the network traffic comes in. If you have a fast enough internet connection, then your VPN can give you up to 1.25 gigabits a second of throughput. If that's not enough, then Direct Connect is that service where you can get a dedicated 1 gig or 10 gig Ethernet circuit from your data center into the AWS data center.
Nice.
We won't look at Direct Connect in this video because I don't have that sort of connectivity in New Zealand. It's not actually available in this country. But we will look at it later on because it is available in the US, and with the CTO Advisor data center, we're going to have some Direct Connect fun going on.
Yeah, we're definitely working. We're working with just so you guys know, we're working with CTO Advisor in some future projects that we'll be talking about. Can't talk about it now, but that'll involve some 10 gig connections for sure.
Yeah, that's going to be really fun to show. And you know, I've never seen it actually set up from start. I've only looked over the shoulder of one of my students on a course where he was showing me their Direct Connect configuration. Yeah. So that's going to be really fun to have a play with.
Awesome, awesome.
So when we're looking at our VPC, it has 2 ways of connecting outside. The internet gateway provides us public side, internet accessible connectivity in and out of our VPC, and then the virtual private gateway, VGW, which provides us the private side connectivity. Often we'll have both of these on a single VPC, but you can have just one or the other. The next thing we need to set up is a thing called a customer gateway. The customer gateway is defined inside a particular region. So for me, it's defined in the Sydney region. That's that collection of availability zones, but the customer gateway is defined in the region. Okay. And it represents your on-premises router. So the customer gateway is not something that AWS provides. It's a representation of something you provide. So you typically have your own WAN router, and this is where the VPN connection for us is going to come in. The customer gateway is our router. It's not an AWS thing. Okay. We can have multiple customer gateways. Now there's a whole lot of scenarios. I'm going to stick to a really simple deployment scenario in the end here, but there's a whole lot of high availability scenarios where you have multiple routers, and therefore we define multiple customer gateways. And what we're going to do is establish a VPN between the customer gateway and the virtual gateway. And that's going to provide us the connectivity from the VPC that the virtual gateway is attached to the customer gateway, our network. And one of the nice things is when we set up that VPN connection, AWS actually provides us some sample configurations. And when we come to stand this up in the next video where we do this actually hands-on, I'm just going to copy and paste the commands out of that sample config straight into my router here. And the network will come up as a result of me taking those commands out. So this customer gateway is a representation of my on-premises router. It can directly drive the configuration of my on-premises router.
Nice.
And then one of the important things as we go through this is how routing turns up. So how our on-premises network learns about networks inside of AWS. And it can be done two ways. It can be done with static routing where you say, at the other end of this VPN is this particular subnet and this particular subnet is at the other end. And you statically configure it, you as an administrator set that up. But we can also use the Border Gateway Protocol or BGP and do dynamic routing. And this is what we're going to do when we go hands-on with this, because all we have to do then is say these two systems know about their own routing and can exchange information about routing between them. We don't have to manually configure the routing.
Okay.
So dynamic routing is quite desirable because it's one less thing that we have to administer. But not all on-premises routers support BGP, and so we do have the option to use static routing as well.
All right.
I'm not going to go too deep into that as well. This is the kind of rabbit hole of things to learn that goes for a very long way, as all of the areas we've looked at with AWS do.
Okay.
So when we establish this VPN connection, it's going to be an IPsec VPN. IPsec is a good standard for authenticating both ends. Both ends authenticate with one another and then agree how they're going to encrypt traffic that's transferred. And this VPN connection that we define links a particular virtual gateway to a particular customer gateway. So the virtual gateway is attached to the VPC, the customer gateway represents our on-premises router. So BGP or static routing on that VPN. At the virtual gateway end, AWS always provisions two endpoints, two IP addresses that your VPN can connect to, and that results in two tunnels. So you have the ability to have two VPN tunnels from your on-premises router to AWS. So there's redundancy at the AWS side, even if you don't implement redundancy at your side.
Okay.
These two VPN tunnels, these two VPN endpoints, can't be aggregated into a bigger link. Just with the way that the virtual gateway behaves, we in fact only use one of them, so it's an active and standby configuration. In terms of the IPsec initial authentication, there's two ways we can do it. The simplest way is pre-shared key. So there is essentially a password that's generated on the virtual gateway and that is in that config file that we're going to download and use to configure our local router. So pre-shared key is essentially a password. But we can also use certificates. We can set up that trust between your router and the virtual gateway through certificates to establish that trust.
Okay.
And just returning to that fundamental limit, 1.25 gigabits per second throughput on your VPN connection. That's the most that you can possibly get through the VPN connection to a customer gateway.
Can
That's
that
not
ever
sufficient for your business requirements. You need a different solution.
Yeah, so that will never increase. That's at its maximum.
That's the maximum for a VPN connection into a virtual gateway. We'll talk in another video about the transit gateway. Now, I mentioned that when we talked about VPC peering, because VPC peering gets complex when you've got multiple VPCs. Well, the VPN side can get complex as well, but also transit gateway is much newer than this. And transit gateway allows us to aggregate together multiple VPN connections.
Okay.
So there are some scenarios where you use transit gateway and VPNs in order to get more throughput. So here's how it works out. I'm going to start with our VPC, and I've just done our placeholder VPC here that just has a single availability zone. Normally you'll have multiple availability zones in here. First thing we'll do is we'll provision up this customer gateway. So the customer gateway gets created and attached to our VPC to allow that private side connectivity to come out. Then we're going to define our customer gateway. So we have the virtual gateway, then the customer gateway, and then the VPN connection between, two VPN tunnels between. And this is what we end up with stood up What we should be able to see is on the customer gateway and we should be able to see the customer gateway definition, the two tunnels coming through the VPN. We should see those both stood up when things are working correctly, but one will be active, one will be standby effectively.
Okay.
We can have multiple customer gateways. We might have multiple data centers in our on-premises environment, and each of them has their own VPN connections back to that virtual gateway. So this would allow us to have multiple of our locations that each independently have access to our VPC inside AWS. But you can see that we've now got a lot of VPN connections. The other thing we can have is multiple VPCs. So we might have multiple VPCs with different applications in them that then connect back to our on-premises single customer gateway.
Okay.
And I haven't drawn the diagram because it was getting really complex when I had multiple VPCs and multiple customer gateways. But you can imagine that then starts getting really complex because every customer gateway, every one of our our on-premises routers has to connect to all of the VPCs, and it gets to be really ugly. That's where Transit Gateway starts to pay off much better than having all of these collections of independent connections.
Yeah, I would hate to have to administer that if it gets beyond 4 or 5 of these VPCs.
Yeah, and you can imagine if we have 3 of our customer gateways, 3 different sites, or potentially we can have multiple of our customer gateways providing redundant connections into a single site. And then multiple VPN tunnels, yeah, it gets complex really fast.
Okay.
Particularly when we add in then that these 3 VPCs probably have VPC peering amongst them because they're not doing their routing to one another through our on-premises. Usually we want that routing between one another inside our VPCs or across our VPCs to happen inside AWS. And so we've probably got VPC peering going in here. That's the sort of scenario where we've got multiple layers and places where things are connected that it gets really complex fast, and Transit Gateway helps to simplify. So we will definitely take a look at Transit Gateway.
Okay, good.
So the process to set up a VPC to on-premises VPN connection. We create a virtual gateway and we attach it to a VPC. We can choose at this point to update the route tables and the firewalls, the security groups and NACLs inside that VPC. We can do that later, or we can do it straight away now, but those route tables are going to point to the virtual gateway on those subnets. Once we have a virtual gateway, we then define a customer gateway, our on-premises router, and then link the two together with a VPN connection. Once we have the VPN connection, we can download a configuration and apply it to our on-premises router, at which point, after a little delay as the VPN negotiates and establishes, we'll have connectivity between our on-premises network and network in AWS. We'll be able to access resources inside our VPC that are not accessible from the public side. That's the key thing about doing this VPN, is to get access to resources from the private side of our network, from those private subnets that the internet never reaches into. Well, that's the theory.
It's a good theory.
And I think, Jeffrey, you saw again the complexity that we can get into in this networking, joining together all of these different objects.
Yeah, absolutely.
And I think that's probably one of the big takeaways in this, is that this does get complex pretty fast.
We talked about the complexity. Let's talk for a second about any of the costs. Are we still keeping within a budgetary area, or are we going to start to shoot through the roof?
Well, it depends what we do. So AWS likes to make money, and so they charge for all kinds of different things. So there is a connection cost. Actually having that VPN connection defined has an hourly cost. And then one of the big things that people get surprised about when they start using AWS is the cost of getting data out of AWS. There is no cost for moving data in. So network packets going into AWS typically cost you nothing. There are a couple of scenarios where you can get charged for it, but the headline is it's no cost to get in, but it's a big cost to get out.
Okay, so it's like the bouncy ball. If the bouncy ball goes in, it can bounce wherever it wants to, but then when it bounces out, that's done. Yeah.
Yeah, and this is why we sometimes see a reference to Hotel California.
Ah,
Once you check in, you can never check out because of the cost. So egress charge, as it's referred to, is a significant thing for AWS, and it can be a big surprise if you haven't accounted for it.
yeah.
So typical egress costs are of the order of 5 to 10 cents per gigabyte transferred out of AWS.
Wow. Okay.
So if you're moving tens of terabytes and petabytes of data on a regular basis, this is going to be a big cost. And this is true for pretty much every AWS service. If you are moving data out of AWS, you are going to be billed for it.
So
And
if you got 10 terabytes, let's say you have 10 terabytes of data a month that you're moving back and forth, is this the best solution for doing this with your business?
well, one of the things we'll look at is when we look at direct connectors, we'll see that data transfer costs on direct connect are lower. The costs we're looking at here are internet-based data transfer costs. So that's of the order of 5 to 10 cents per gigabyte. You really do need to look at the AWS site to find the actual costing for that.
Okay.
When we use direct connect, the data transfer cost is significantly lower. For some customers, and particularly customers who move a lot of data out of AWS back to on-premises, direct connect can end up being more cost effective than VPN. Even if they don't need the additional bandwidth, the lower data transfer out cost can be offset the cost of having the direct connect link itself.
Okay. Yeah, I suppose if you get to like 10 terabytes of data a month, you're probably talking to a couple AWS professionals to make sure that you're doing everything right and nothing is getting lost in translation.
Yeah, and the key thing in the end is, are you getting value for the money you're spending? It'll work out whether that 10 terabytes being transferred at whatever the actual end cost of that is, does that represent value for the business? And that's always got to be the decision. You know, one of the challenges I see is people have a discussion about minimizing cost, but what they really should be having a discussion about is maximizing value. I can minimize your AWS cost, cancel the credit card that's used to pay the AWS bill, and you will no longer get a cost from AWS, but you'll get no value from AWS.
Mm-hmm.
So yeah, it's worth looking at maximizing value. But one of the weird things, and this is completely off topic here, one of the weird things about AWS is that they have these management principles that govern what their staff do. Most organizations have management principles and they're written on a plaque in the executive suite, and the staff don't even know what those principles are. AWS has a bunch of management principles. And if you ever go for a job at AWS, go learn what those management principles are and what they mean. One of them is frugality. So don't waste money. One of the core management principles. And the weird thing in AWS is these management principles are known to pretty much every employee, and they drive the decisions the employees make, because one of the management principles is to empower the employees to make their own decisions. So frugality is one of the management principles, and it means that an AWS employee who is consulting with a customer is always trying to reduce the AWS spend for the customer while maximizing benefit.
Okay.
So a new AWS solutions engineer who goes to a new customer is tasked with reducing the amount of money that customer spends to get the services they're currently using. And so they'll help you with, if you buy your EC2 instances in this way, it will cost you less money and deliver the same value. It's completely weird. This is not the way enterprise IT works at all. A salesperson goes and visits you from an enterprise customer. They always want you to spend more money.
Give me money.
AWS is interesting.
Yeah, give me money. Give me money.
But frugality says, let's not waste your money.
Yeah, absolutely. Well, that's interesting to know, and a good side note there. Let's get back on track though, because we've got a second part to get to. So we're gonna do the hands-on thing.
We're gonna build this stuff, aren't we?
What was that?
We're going to build this stuff. We're going to build a VPC, a VPN between a VPC and my on-premises enterprise network.
There we go. All right. Well, we're going to do that. That's going to be the next video in the series. If you haven't gone over to the YouTube page and subscribe to the playlist, go do that now. You don't want to miss out on this hands-on. And of course, the whole structure from episode 1 to now is going to be in that playlist. So go ahead and subscribe, like, and comment. We're going to be having a Q&A section in a couple weeks to answer any of the questions that you might have over any of the content that we're we're covering here on AWS. And of course, with Build Day TV, we are going beyond AWS, and we're going to be working with other vendors, and we're going to be working in other situations where Alastair is going to be putting together, or we'll have special guests come on and do that. So if you're a specialist in a field and want to talk to us about it, feel free to contact us here at Build Day Live, and we'll go from there. So go ahead, like, subscribe, comment, and Alastair, if you're ready, let's get to the next video, and I want to find out how this all works.
All right, we'll see you in the next video.
Okay, we'll see you then.